In just a few years, um, quantum computers could theoretically become powerful enough to just totally shatter the encryption protecting your bank accounts.
Yeah, your private messages, your entire digital life, really.
Exactly. So why did a free open source project named after a raccoon just become one of the first operating systems on Earth to deploy quantum-proof armor for the everyday user?
Well, I mean, it sounds like science fiction when you put it that way, but it is the reality of where software has to go.
Right.
You cannot build a modern house on a cracked foundation, you know? And right now, the foundation of personal computing is undergoing a massive seismic shift.
Okay, let's unpack this. It is late April 2026, and just 2 days ago, Canonical dropped Ubuntu 26.04 LTS.
Which is a huge deal.
It is. Its official name is Resolute Raccoon, which, by the way, is a really touching tribute to the late developer Steve Langesek.
Yeah, it really is.
But this release has the entire open source world buzzing and, in some corners, absolutely screaming.
Oh, definitely screaming.
Right? So the mission for today's deep dive is to sift through the official Canonical release notes, the community reactions, and the technical reviews.
They get the full picture.
Exactly.
Yeah.
We want to figure out if this update is a brilliant leap forward or just a deeply frustrating hurdle for longtime users.
And there are arguments for both sides.
For sure. But before we get into the crazy stuff like quantum encryption or AI workstations,
Yeah.
can you just ground us for a second?
Yeah.
What does an LTS release actually mean for you? You know, the person listening right now may be installing this on your laptop.
Gladly. So LTS stands for long-term support. In the Ubuntu ecosystem, you have standard releases that happen every 6 months.
Okay.
You can think of those as stepping stones. They are where Canonical tests out new ideas, works out the bugs, that sort of thing.
Like a testing ground.
Right. But every 2 years, they roll up everything they've learned, in this case, from the 24.10, 25.04, and 25.9 intermediate releases, and they bake it into a rock-solid, enterprise-grade foundation.
Which is the LTS.
Exactly. For you, the user, installing an LTS release means you are guaranteed 5 years of standard out-of-the-box support.
5 years. So that takes us to April 2031.
Which is a complete eternity in the tech world.
It really is. A lot can change in 5 years.
It is, but if we connect this to the bigger picture, it goes even further.
Wait, really? How so?
Well, if you use Ubuntu Pro, which, by the way, Canonical provides completely free for up to 5 personal machines, you get 10 years of expanded security updates.
Oh, wow. 10 years.
Yeah. That means an operating system you install today will be officially supported until 2036.
2036. That's wild.
And that decade-long lifespan is the absolute crucial context for almost every controversial decision we are going to discuss today.
Because they have to look so far ahead.
Exactly. Canonical isn't building an operating system for 2026. They're building an operating system designed to survive the 2030s.
And surviving the 2030s apparently requires a massive amount of firepower.
You can say that again?
So let's jump right into the biggest shockwave rippling through the community. Let's talk about the hardware requirements, because this raccoon has developed some incredibly expensive taste.
What's fascinating here is how much the baseline has shifted practically overnight.
It's a huge jump.
Ubuntu 26.04 now officially recommends 6 gigabytes of RAM for a comfortable desktop experience.
6 gigs.
Yeah, and it also calls for a dual-core 2 gigahertz processor and 25 gigabytes of disk space.
Okay, to put that into perspective for everyone, the previous LTS release, which was 24.04, only recommended 4 gigabytes of RAM.
Right, a 50% increase.
Wait, I really need to push back on this, because doesn't this betray the entire cultural ethos of Linux?
What?
Because historically, right, Linux is famous for breathing life into old, dying hardware.
That's a stereotype.
The whole cliche is that when your Windows machine gets too bloated and slow, you just install Linux to save it from the landfill.
Right, right.
But now, this new operating system is just adding more memory than Windows 11 in some basic scenarios.
It is.
I joked earlier about the raccoon, but it seriously feels like our friendly neighborhood trash panda has suddenly developed a taste for, like, premium, organic, artisanal garbage. It is getting incredibly picky.
I completely understand the frustration, and honestly, a lot of the community feels exactly the way you do.
I mean, it's all over the forums.
It is. The accusation floating around everywhere is that Ubuntu has become bloated.
Right.
But when you actually look at the architecture, it isn't bloat. It's modernization.
Okay, sell me on that.
Well, Ubuntu 26.04 ships with Linux kernel 7.0 and the brand new Genome 50 desktop environment.
Right, but what do kernel 7.0 and Genome 50 actually do? If I'm giving up 2 extra gigabytes of my RAM, what exactly am I buying with that memory?
You are buying a genuinely premium hardware-accelerated visual experience that finally matches commercial operating systems.
Like Mac OS or Windows.
Exactly. For example, this release features native variable refresh rate, or VRR.
Oh, that's where the monitor physically changes how many frames it draws per second to match what the computer's outputting, right? So you don't get screen tearing.
Exactly. And doing that seamlessly across multiple monitors with different refresh rates requires constant, real-time memory buffering.
Which eats up RAM.
Yes. Then you have vastly improved fractional scaling.
Oh, fractional scaling used to be such a nightmare.
A total nightmare. In the past, if you had a 4K monitor and you scaled the interface to, say, 150%, so you could actually read the text.
It often made everything look super blurry.
Blurry, or it caused the processor to work twice as hard. But Genome E50 handles fractional scaling natively, rendering text and UI elements with perfect crispness.
Okay, so it looks a lot better.
Much better. Add to that the incredibly fluid animations and low latency, particularly if you are using an NVIDIA graphics card or running this on one of the new ARM-based Snapdragon laptops.
I've heard the Snapdragon performance is amazing.
It is. But to render those high-quality graphics and manage the frame pacing, the system simply cannot operate on 4 gigabytes of RAM without stuttering.
So it's a deliberate trade-off. Canonical is essentially saying, we are no longer trying to be the lightweight savior of your 15-year-old Dell laptop.
Yes.
We are building a modern workstation.
Precisely. If you want a lightweight Linux to revive old hardware, Ubuntu 26.04's default Genome desktop is simply no longer the tool for that specific job.
You'd have to look elsewhere.
Yeah, there are other distributions for that, Ubuntu, Lubuntu, things like that. But this is a heavy-duty engine.
Okay, but drawing pretty animations doesn't take 6 gigs of RAM on its own.
No, it doesn't.
So if the system is consuming more of your machine's memory, what exactly is it doing with it in the background?
That is the big question.
Well, it turns out it's building an absolute security fortress. Let's talk about the hardware-based security, because this ties right back into your point about surviving the 2030s.
But security architecture in 26.04 is a massive leap forward. For starters, TPM-backed full disk encryption is no longer an experimental feature you have to opt into via some complex command line interface.
It's just there by default.
It is the standard.
And TPM is the trusted platform module, that little dedicated security chip on your motherboard. But how does that actually change the security of my files?
Let's say you encrypt your hard drive with a standard password.
Okay.
If someone steals your laptop, they can theoretically pull the hard drive out, plug it into a massive server farm, and run automated programs to guess your password millions of times a second.
Like a brute force attack.
Exactly. But with TPM-backed encryption, your decryption keys are physically logged inside that specific chip on that specific motherboard.
Oh, wow.
The hard drive literally cannot be decrypted if it's removed from the computer. It binds your data to the physical hardware.
That makes offline attacks incredibly difficult.
Nearly impossible for the average thief.
And I noticed they've also overhauled how applications interact with the system once you're actually logged in. Canonical has deeply integrated Aparmer with their Snap applications to actively prompt the user for granular permissions.
This is a profound shift for desktop Linux. Historically, if you installed an application, it generally had access to your entire home folder.
Which is kind of terrifying when you think about it.
It is, but now it operates on a smartphone model.
Yes. I saw this in the release notes. If an application wants to use your webcam, or record from your microphone, or access a specific folder in your documents,
You get a pop-up.
yeah, a prompt physically pops up on the screen asking for your explicit permission. It doesn't just get a blank check anymore.
Which is exactly how an operating system should isolate processes. But the most futuristic part of the security fortress is what you mentioned in the introduction.
The post-quantum cryptography.
Exactly.
Here's where it gets really interesting.
Yeah.
Canonical has included default post-quantum cryptography in several core system components.
Which is huge.
Now, I try to keep an open mind, but I have to ask, isn't post-quantum encryption massive overkill for a regular user who is just, browsing the web, checking email, or writing a bit of Python code?
It does sound like it.
Right. Because I don't have nuclear launch codes on my laptop.
It sounds like overkill until you understand the concept of harvest now, decrypt later.
Harvest now, decrypt later.
Okay. Malicious actors ranging from state-sponsored hackers to organized crime are currently scooping up massive amounts of encrypted data across the internet.
Just hoarding it.
Yes, they can't read it today because standard algorithms like RSA would take a traditional computer thousands of years to crack, but they are just storing it in giant data centers.
Waiting for quantum computers to arrive.
Exactly. A sufficiently powerful quantum computer could break that encryption in minutes.
Wow.
And the general consensus in the cryptography community is that by the early to mid-2030s, those quantum computers will be a reality.
And going back to your earlier point, Ubuntu 26.04 is supported until 2036.
You got it. If we connect this to the bigger picture, by implementing post-quantum cryptography today, Canonical is future-proofing the OS.
They're beating the hackers to the punch.
They are ensuring that the digital handshapes your computer makes today cannot simply be harvested now and decrypted a decade from now.
Okay, when you frame it around the harvest now, decrypt later threat, that actually makes perfect sense. It's not overkill, it's just planning ahead.
It's the only responsible move, really.
And I noticed that forward-thinking approach extends to the actual code the operating system is written in. Canonical is actively shifting many critical system components to Rust.
Yes, and this is another reason why the memory footprint has changed.
Oh, really?
Yeah. They've implemented a new version of the sudo command, which, is the command you use to grant yourself administrator privileges, and they wrote it entirely in Rust. It's called sudos.
But why does the programming language matter to the end user? Code is code, right?
Not exactly. Much of the traditional Linux ecosystem is written in C or C++ EA. These are incredibly fast languages, but they are not what we call memory safe. They allow developers to accidentally write data past the chunk of memory they were officially allocated.
This is a buffer overflow.
Exactly. Imagine you have a cup, which is your buffer, and you pour too much water into it.
It spills.
The water spills over into the area around the cup. In programming, if an attacker can deliberately cause a buffer overflow, they can spill malicious code into a part of the system's memory they aren't supposed to have access to and hijack the system.
And Rust stops this.
Mechanically, yes. Rust enforces strict boundaries at compile time. It checks the size of the cup before it ever lets the program pour the water.
That's a great analogy.
Thanks. Academic security comparisons consistently show that eliminating these memory-related bugs drastically shrinks the attack surface of an operating system.
So the fortress is secured against quantum computers, and the walls are built with memory-safe Rust to prevent overflows.
Exactly.
But a fortress isn't very useful if it's totally empty. What can you actually do inside this system?
Now we get to the fun part.
This brings us to the user experience and the massive focus on AI workstations.
Right. Ubuntu 26.04 is explicitly positioning itself as the ultimate deployment platform for artificial intelligence and machine learning.
AI is everywhere now.
It is, but they aren't just using AI as a marketing buzzword. They've baked the heavy lifting into the repositories. You now have native support for NVIDIA CUDA and AMD RCM.
Okay, let's break those acronyms down.
Yeah.
CDA and ROCm are essentially the software platforms that allow a graphics card to do parallel computing, right?
Yes.
To process complex AI math instead of just rendering video game graphics.
Correct. And historically, getting those platforms running on Linux was an absolute nightmare.
Oh, I remember. The forums were full of people crying over broken drivers.
You had to go hunting through NVIDIA or AMD's websites, download proprietary drivers, wrestle with conflicting installation scripts, and pray that a kernel update didn't break your entire setup the next day.
It was so fragile.
Extremely. By putting native support directly into the official Ubuntu repositories, Canonical is saying to developers, just install the OS Type 1 command and your GPU is instantly ready to start training machine learning models. It just works.
Which is an absolute godsend for developers.
Yeah, definitely.
But even for everyday users, AI is creeping into the system in subtle ways.
Yeah.
The default app lineup has been totally refreshed.
Yeah, they really cleaned house.
There's a new image viewer called Loop, a new video player called Showtime, and a completely new terminal application called Fakemas, which integrates beautifully with Genome 50.
QTexas is fantastic.
But the one that really caught my eye is the new system monitor called Resources.
Yes, which is another application written in Rust, by the way.
And what's wild is that it doesn't just track your CPU and your RAM anymore. It actively tracks your GPU and your NPU, your neural processing unit, along with real-time clock frequencies.
Right.
Watching it visualize the load on your AI hardware really highlights how machine learning has become just a standard part of our daily computing diet.
It really does. However, interacting with all this new software brings us to a major change in how you actually install applications. And this is where Canonical starts stepping on some toes.
Ah, yes. The beloved Genome Software Center is officially gone.
RIP.
It has been entirely replaced by Canonical's proprietary App Center. Now, on the surface, it looks gorgeous.
It really is a nice UI.
It unifies Snap packages, global search, and something called XDG portals into one really polished interface. But installing third-party .deb files, the classic Debian installation packages that you download directly from a developer's website, is now deeply unintuitive.
Let's explain why that is. It goes back to that smartphone model of security we talked about earlier. Canonical is heavily pushing Snap packages. A Snap is a self-contained software bundle. It includes the application and every single dependency it needs to run, all sandboxed away from the rest of your system.
So it can't accidentally break another program by updating a shared file.
Exactly. And because it's sandboxed, it needs a secure way to talk to your operating system. That's what an XDG portal is.
Okay.
If a sandbox Snap app needs to open a file, it can't just browse your hard drive. It sends a request through the XDG portal to the operating system. The operating system opens a secure file picker. You choose the file, and the operating system hands only that file back to the app.
So Canonical loves snaps because they are secure, they update seamlessly, and they run exactly the same way on any Linux machine.
Yes. For a beginner, the new App Center is fantastic. It makes the system feel incredibly polished, secure, and foolproof.
But for power users,
it is deeply frustrating. Power users like native .deb packages because they are lightweight. They share system resources instead of duplicating them inside a sandbox. They give you fine-grained control over your machine.
it feels like moving into a beautiful, hyper-secure smart home. But the landlord is telling you that you aren't allowed to bring in your own vintage furniture.
That's a great way to put it.
Everything has to be bought from their pre-approved sandboxed catalog. And that tension naturally leads us to the most controversial part of this entire deep dive.
Here we go.
Because to enforce this secure, sandboxed future, Canonical had to intentionally kill off the legacy architecture that Linux has relied on for decades.
This raises an important question about the fundamental cost of progress. To build this smart home, you have to bulldoze the old house.
Right.
And in Ubuntu 26.04, the native X11 session has been entirely removed from the default Genome desktop.
X11, or Xorg, being the display server protocol that draws the windows on your screen.
Right. X11 was designed in the 1980s. It was the absolute standard for decades. But its architecture is fundamentally insecure by modern standards. In X11, the display server acts like a giant open bulletin board. Every application on your desktop can see what every other application is doing.
Wait, so if I have a malicious app running in the background, it can theoretically log every single keystroke I type into my banking app just by watching the X11 bulletin board?
Precisely. It is a keylogger's dream. Wayland is the modern replacement. Wayland acts like a highly secure, isolated vault for each application. App A cannot see what App B is drawing on the screen or what you are typing into it. Wayland is what makes the secure sandboxing of Snap packages and AppArmor actually work.
Canonical did leave something called X-Wayland as a compatibility bridge,
Yeah.
so some older apps can still run, but the pure X11 environment is completely gone by default.
Gone.
And it's not just the display server. I was reading through the technical changes, and cgroup v1 is completely dead. Only cgroup v2 is supported now.
Let's demystify row groups, or control groups. Imagine you have a house with a limited amount of oxygen. That's your CPU and RAM.
Okay.
A key group is essentially a way to put a specific application into a sealed room and dictate exactly how much oxygen it is allowed to breathe so it can't suffocate the rest of the house.
Got it.
It is the underlying technology that makes things like Docker containers possible.
So why is the shift to cgroup v2 a big deal?
Version 1 was messy. Different resources were managed in separate hierarchies, which caused conflicts. Version 2 unifies everything under a single, efficient hierarchy. But it breaks older legacy container setups that were hard-coded to look for the version 1 structure.
And it doesn't stop there. The default system for the initial boot process, the initramps, has been swapped over to a tool called Dracket.
The initramps is essentially the starter motor for your operating system.
Okay.
When you press the power button, the computer doesn't know how to read your hard drive yet. It loads a tiny temporary file system into your RAM, the initramps, which contains just enough drivers to find your hard drive, unlock your encryption, and start the real operating system.
And Dracket is just a more modern way to build that temporary file system.
Yes, it speeds up boot times and improves hardware compatibility, but again, it fundamentally changes how power users troubleshoot their systems if a boot fails.
So what does this all mean for you, the listener? Say you rely on older, hyper-specific workflows. Maybe you have a custom X11 script you've used for a decade to manage your multiple monitors, or you are running legacy Docker containers for your business that rely on cgroup v1.
For those users, the community has rightly labeled this as one of the most daring LTS releases in years.
Daring is a polite word for it.
It is. The cost of all this incredible security and graphical performance is that older hardware with unresolved Wayland quirks and highly specific legacy applications will simply break.
Yeah.
For a certain subset of users, this release won't just be a learning curve, it will feel genuinely bad because it breaks the tools they rely on.
Okay, let's synthesize everything we've uncovered today. We've got an operating system demanding 6 gigs of RAM to fuel a buttery smooth, Wayland-driven graphical experience.
Yeah.
We've got a post-quantum security fortress guarded by a Parmer, PPM, and Rust. We have an AI-ready environment with native CEDA and ROCm support, all pushed through a brand new, highly sandboxed app center.
Yeah.
And to make all of that happen, we have the definitive intentional death of X11 and legacy system components. So what is the actionable advice for the person sitting at their desk right now, staring at the upgrade to 26.04 button?
The actionable advice is proceed with strategy. Ubuntu 26.04 Resolute Raccoon is a necessary, brilliant step into an AI-ready, highly secure future. But you must test your environment first. Do not just upgrade your primary work machine blindly.
Never a good idea anyway.
Put this on a live USB drive or spin it up in a virtual machine. Test your specific hardware, your specific monitors, and your critical daily applications inside the Wayland environment to ensure they function properly.
And if you find that you rely heavily on X11, or if you have a machine with low RAM that starts choking on the new Geno 50 desktop, what then?
Then you stay exactly where you are. Ubuntu 24.04 is an incredibly stable LTS release, and it is safely supported until 2029.
Oh, it's plenty of time.
You have 3 full years before you are forced to figure out your legacy dependencies. There is absolutely no rush to jump ship today.
And here's a fun tip.
Yeah.
If you do decide to take the plunge and the raccoon happens to, bite you with an early release bug, don't panic.
Never panic.
The Ubuntu community on Reddit, Discourse, and Ask Ubuntu is massive. It is full of real, dedicated people who are ready to help you troubleshoot your setup. You are never alone when you're using open source software. You just have to ask for help.
That is the enduring beauty of this ecosystem. The technology under the hood changes, sometimes violently, but the community remains to guide you through it.
Which brings us to the end of our deep dive into the Resolute Raccoon. But before we go, we want to leave you with one final thought to mull over as you look at your own hardware.
We've talked a lot about the massive leap in requirements.
We have.
If Canonical's flagship Linux, an operating system long championed by the public as the agile, run-on-anything alternative to Windows, is now demanding 6 gigabytes of RAM just to power post-quantum encryption and AI-driven desktop environments.
Are we officially witnessing the end of the lightweight Linux era as the default standard?
That's the question.
It really makes you wonder. If the old foundation has officially been demolished to make way for the future, what happens to all the hardware that can't support the weight of the new world?
Exactly.
What new, undiscovered operating system will rise up to claim the millions of older, perfectly good machines that have just been left behind in the dark? Think about it. Thanks for joining us, and we'll catch you on the next deep dive.